Hello, everyone. Welcome. I am joined today by a very special guest, Dr. Alan Stern, the primary investigator of the New Horizons mission, which visited Pluto in the year 2015. How are you today, Dr. Stern?
Hey, I'm doing great, Luke. It's wonderful to be here with you.
Oh, it's an absolute pleasure because I've known you since 2006, at least your name since New Horizon launched, and just and especially in 2015, watching the data come back and the images was fantastic. But besides being the primary investigator of New Horizons, could you tell us a small sample of the 24 plus missions you've worked on?
Well, I've worked on actually now 30 different space mission teams, 4 space shuttle missions, 14 suborbital sounding rockets done from White Sands, New Mexico, and Poker Flat, Alaska. A whole slew of planetary missions, both ESA and NASA missions. And I've used a lot of space telescopes, like the Hubble, and FUSE, and EUVE, and IUE, and a whole bunch of other alphabet soup telescopes in Earth orbit.
Fantastic. And it occurs to me we should definitely talk today at some point how someone could follow in your footsteps if they're younger and interested in a career in planetary sciences or the astronomy of the solar system.
Sure, I'd be happy to. I mean, I
Great.
followed amazing people's footsteps, and I was lucky enough to get to do exactly what I wanted in my career.
Mm.
Got to pay it forward.
It's truly inspirational, and we'll talk about all of that, and especially, hold on, wait, without looking. Yep, got it. So, Dr. Stern, everyone, has written along with David Grinspoon the really exciting account of this whole mission, going to what was once thought to be the farthest planet in the solar system. Now we know that Pluto is really just the first among dozens of similar worlds way out there past the orbit of Neptune, which Kuiper Belt objects, as they're sometimes called. Truly fascinating. And what was it? A little bit about the book, if you could tell us, Dr. Stern, writing with
David and I signed a contract to write this in 2016. There we go. Get it in the right place. And I call it my 100 Lost Weekends. I worked on it every weekend for 2 years with David. We wrote it, and then we rewrote it, and we rewrote it, and we rewrote it, and we rewrote it, and then we turned it into the publisher, and they said, we love it. It's 200 pages too long. No one will read it. It's 500 pages. They said, you have a month to cut it down or we're canceling the contract. So David and I went back to work, and we took a lot of the stories out. So maybe there'll be a second book someday. But I'm still very happy with how it turned out. And
I love it.
Thanks for telling people about the book.
Yeah, everyone, this is absolutely worth reading, especially if you have the smallest amount of interest in how planets get explored, which is still something that's only done, obviously, by robotic exploration, and has unlocked incredible secrets about the things that we take for granted now that we just understand has been because of robotic missions like the New Horizons mission to Pluto. The link is in the description. It's a great book, a really interesting read. I think it's also great for the layman, which is probably a primary audience you were thinking of, as well as being exciting to someone who's super
interested. For everybody. It's not a science book. It's not an engineering book. There's some of that under the hood stuff in a couple of chapters. So nerds like me will love it. But the real thing is it's a story of persistence and a group of people who just wanted to top Voyager. A little bit of unfinished business. They stopped at Neptune. We need to go do Pluto and find out what that place is all like. It took 26 years to pull it off. And we had uncountable numbers of defeats. I used to say if the New Horizons mission had been a cat, it would have been dead long ago because cats only get 9 lives. And New Horizons had a lot more than that. So the book tells that whole story, the political intrigue, the science behind it, how you actually go about competing and winning and then building a space mission. In this case, a pretty risky one because we only sent 1 spacecraft on this lone journey across the solar system, fastest spacecraft ever launched. And it all came down to just a couple of weeks in July of 2015. Is it going to work or not? And it was our moonshot. It was tremendous.
Completely. It was riveting because being just such an aficionado of all this stuff for so many years, and just waiting. Like I would remember like at least once a year, just checking, hey, where's New Horizons? I have to wait till next year. Okay. And then I was in flight school, actually. I was in flight school in the beginning part of one of the classroom theoretical parts of flight school in Fort Rucker, Alabama. And I was watching the updated, like whatever website I could find that would have the newest images that you all were putting out from the team. And just because it went from, in a matter of weeks and then days and then minutes, from being just a little speck, not much better resolve than Hubble could do, which is still, better than what we had before. And then suddenly we're starting to see features and shapes, and then eventually color. And while we chat about it, I'll even open a little image of the incredibly beautiful Pluto. How shocked were you when you got to see what this thing looked like?
We on the team, who had spent our careers making it our business to know everything that was known about Pluto, could tell it was going to be something special. But this exceeded all of our expectations. I really think, in a way, the solar system saved the best for last.
Yeah, I think so too. It was because it's just startling. Like how can it look like? Hold on, I'm trying to make this available. Oh, it's not letting me do it. Wait, maybe it will. Aha, there it is. Good. Of course, there it is.
There you go.
Now, when about, if you, I don't know how well you remember the exact, date or the process, but Pluto had already passed through, of course, and it was hours later, 6 hours-ish before you got data like this back?
Actually, it was the next day before we got this. It was about 9 hours before we even knew if it had worked.
Wow. Yeah, unbelievable. And is this true color, by the way, or is this slightly enhanced?
This is enhanced color. Pluto is, as you can see, different surface units have different colors, but you have to stretch the contrast to bring that out.
Yeah, but it's being able to see the contrast shows us immediately this is not a dead object like Spock described the world in Star Trek II, essentially a dead rock in space. And it couldn't be anything more opposite as far as the dynamism. Like I've heard you say before, if Captain Kirk were looking out of this bridge of the Starship Enterprise, a planet would look like this. And it looks so much like beautiful fictional planets from the 60s even.
It is a sci-fi planet in many respects, Luke. Some of the things that we see, like methane snow-capped mountains and haze layers that stretch hundreds of kilometers into the sky, giant cryovolcanoes, convecting glaciers. I could go on. And it really exceeded our expectation. And it rewrote the textbooks about how active small worlds can be. Now, when I say small, I think people ought to realize that the distance from one side of Pluto to the other is not as big as the continental United States, but of that order. Yeah. And so this is a very large place by any standard. And if I can share an image,
absolutely,
I'll give you some scale for that. Let me see if I can learn to share in this app.
Yeah, let's see if it's possible. Please do.
I have to get the right thing out, so let me do that real quick.
Oh, absolutely. Yeah, it was.
Find this quick.
Yeah, just
this image. I want to show you Pluto. This is in true color with no stretch whatsoever. And share the screen. And I don't know what it's going to share.
Let's see what happens. I think you can pick the application specifically, in fact.
I am, but it's not letting me. It's okay. Maybe that'll work. My browser's blocked it. I'm sorry.
Oh, it's okay. Well, if you can send it to me if you want in the meantime, and I can put it up here, if you like.
Anyway, why don't you go ahead?
Yeah. No, it's just the excitement is beyond palpable because it's so inspiring, and I'm sure a lot of people were inspired to follow in your footsteps for sure, and of all the other great people you've gotten to work with. So yeah, Pluto, amazing, and of course, very famously, and I don't even think chagrin is a strong enough word, much to the hardworking New Horizons staff chagrin. In 2006, just a few months after the launch, the International Astronomical Union decided to make a ridiculous pronouncement. I already made a video about it that I think a lot of people have seen.
And that's an awesome video, by the way. It's super entertaining.
Oh, thanks.
Easy for anybody to understand. I got up my popcorn and I watched it a couple weeks ago, which is how we came to do this show.
Of course, yeah.
About 25 minutes, if I remember.
Yeah.
And I loved every minute of it, Lou.
Oh, well, I've loved even more watching the really extended debates you've had with, say, like Ranieri, I think his name is pronounced.
Ranieri?
Yep.
President of the International Astronomical Union.
Yeah, and after I posted it, I ended up having some friendly debates with some people in the comments too, some astronomers and astrophysicists who seemed very dead set on the idea of using orbital dynamics to define planethood. And there's a great graph, I think it was, I'm trying to remember the gentleman's name. You showed it in that debate with Ranieri, where if you take an Earth and you put it, if you have a whole solar system filled with Earths and you put them at the various orbits of the classical 8 or 9 planets, whatever, they're not Earth after a certain point.
Only the first 6.
Yeah.
Yeah, identical objects classified differently. It's a poor classification scheme for most people, and we know that because in the professional literature, there's this amazing planetary scientist down in Florida, Phil Metzger. I don't know where the guy finds the time in the day to do all the things that he does, but one thing that he did recently is that he did a computer-based literature search of all planetary science papers across many technical journals since 2006. And he can't find any papers that use the IAU definition, which is just the community voting with its feet, the experts of the world who publish planetary science, because it's not a very useful definition. The only papers he could find that even mention the IAU definition were papers about the IAU definition. But all of the other scientific references to planets fall within something else that planetary scientists use called the geophysical planet definition, which is much simpler and doesn't misclassify objects and passes the so-called Star Trek test of what would happen if you showed up and saw it on the bridge of the Enterprise, and make a lot of sense from a scientific standpoint. Best of all, the geophysical planet definition was coined by planetary scientists, not astronomers in another field who don't really understand planets. You know, and I'm sure if we as planetary scientists tried to classify galaxies or black holes, we would do a similarly botched job. The really puzzling part of this whole saga has been that from the moment in 2006 that the astronomers made their mistake and their professional society, the International Astronomical Union, became the irrelevant Astronomical Union. From that moment on, the science press have not looked at it critically. They have gobbled up what the IAU had to say, and it's puzzling. Why listen to the experts, the planetary scientists, who just laugh and shrug this off, with rare exception?
And we can do that because we know that a rose by any other name has just as much methane ice on it, but I wonder why it, like after 2006, I would have imagined an immediate revisiting, and the only reason I can come up with, based on no evidence, that the IAU or other people involved with the IAU haven't sought to upgrade that definition is political, that kind of being dug in, being attacked afterwards, and then not wanting to look at it. I don't know. Have you found a solution that you're willing to?
I certainly agree with you that it smells like something political on the part of the IAU that doesn't want to say we were wrong, which is very anti-scientific. We are taught in the scientific enterprise that it's all self-correcting and we try our best, but we make mistakes and new data comes in or new theory or new models. And from that, we course correct all the time. That's how science works in every branch of science. But as an organization, I think they're in defense mode. What puzzles me is why the science press doesn't say, hey, the king has no clothes. Nobody's using this. Why do textbooks adopt it and schools teach it when no one's using it?
Presumed authority, appeal to authority, because, and I think that's a part of scientific literacy, and we, I'm sure, all want more people to have an interest in science and space in general, and to learn a little bit more about detail, so they can make their own judgment, and then to put pressure on, because this is a huge deal, I think, when it comes to Congress hearing then suddenly, hey, Pluto's not a planet anymore. Why are you sending a multi-million-dollar, billion-dollar spacecraft to something that's not a planet? You know, because this It's
There's a
important, right?
degree of importance that's associated with planets for humans because we live on one. We don't live on a star or an asteroid or a comet or a, name your class of object. We live on a planet, so we identify with it. And objects that are planets, we associate with.
Mm.
But it's ridiculous from my standpoint to think that astronomers would want to revise the definition of a planet purely to manage the numbers down, to legislate them to be small so school kids can memorize the names of them. We don't memorize the names of the stars. We don't memorize the names of the asteroids and galaxies. There are too many.
I have
We
trouble
know
with the
them.
zodiac. There's only 12 of those.
Even in earth science, do school kids get asked to memorize the names of all the rivers or mountains of the earth? Of course not. You learn there are lots of them, and there are some famous ones, right? Like the Nile and the Ganges or Mount Everest. And then you go on, and you learn to recognize rivers and mountains. But there's no sense in geology, for example, that we have to restrict the number for the sake of textbooks. And planets should be the same. The galaxy is teeming with them. There's an uncountable number, more than all the grains of sand on all the beaches of the earth. Can't we get over this business about the old days when we used to only know of 9 and therefore we could know all their names? It's so 20th century.
I agree. And we got a great comment from Laurel Kornfeld, who has a blog all about Pluto's planethood. And Laurel, if you're able, put up the link to it, because it's a great resource to look at all the conversations and the debates and transcripts. And she's saying how unbelievable it is the IAU never revisited.
Although I would say, personally, I hope they never touch it again. They botched it to begin with. Don't botch it a second time. And really, I hope your listeners realize why I'm coming at it this way. Astronomers are not expert in planets. They are expert in faraway objects like stars and galaxies, black holes, the universe as a whole. And they're no more expert in planetary sciences than a podiatrist could be a neurosurgeon. But they're different doctors that study different parts of the body.
And I agree. But what, just to play a little bit of devil's advocate, what about when Ron Eckers said how the IAU, doesn't it name or officially catalog or approve of namings of all territories in the solar system and all stellar objects? Aren't they? It
is a clearinghouse for proper names so that we don't have collisions. And I think they've done a pretty good job at that. But when it comes to scientific categorization, what they did in Prague with 5% of their membership in a split vote at the last minute on the last day of a week-long meeting, when they didn't even announce to the larger 10,000 members that this would even be a topic for debate, it was really botched. And unfortunately, I'm still having to talk to people about it 15 years later, when the planetary science community has moved on. I think the public has largely moved on. People look at Pluto, they don't know what to call it but a planet. And the same other planets of the solar system that weren't even known until the 1990s and 2000s because they were too far away to spot. And now we're finding out that the most dominant class of planet in our solar system isn't the 4 rocky planets like the Earth and Mars and Venus and Mercury, or the 4 giant planets, Jupiter, Saturn, Uranus, and Neptune. But that so far, north of 100 dwarf planets. Who's the oddball now?
Yeah, that's right. And
Earth is the oddball.
And I'm just curious if I may ask, how did you feel when, because you were in the early 90s, one who coined dwarf planet to describe Kuiper Belt object, planet-sized things
I did in the scientific
and then it was used.
paper.
Was it? I don't know if it was deliberately against you, but it was used against you. Your term, which is a great term, dwarf planet, like dwarf star, but then used to exclude the very thing that you have spent literally decades seeking to study in great detail.
It definitely felt like a hijacking.
Do you think it was deliberate and conscious?
I don't know. I wasn't there. Who knows?
Fair enough.
Here's what I do know was deliberate, was that the man who discovered Pluto's name was Clyde Tombaugh. He discovered it when he was 24 years old. And in doing that, he actually discovered the Kuiper Belt, the 3rd zone of our solar system, hugely ahead of his time. Nobody made equivalent discoveries again until the 90s. So he was like 60 years ahead of his time. 1930, he discovered Pluto. But along his career, somehow he and a guy named Brian Marsden got crosswise. And Brian swore to him in public in the 80s, in front of other people, that when you're gone, I will erase your legacy. And then Tom Bell died in 97. And in 2006, guess who led the IAU vote? Marsden. And he did erase some of Tom Bell's legacy. And I think it's tragic because the man was amazingly talented and really opened up the true outer solar system way back in 1930 by discovering Pluto.
Yeah. And then there's no doubt that those of us who end up specializing in something, like most of what I get to specialize in these days is the reconstructed phonology of ancient languages like Latin and ancient Greek. And it's amazing how heated we can all get about our opinions and stances. So that's normal. We're passionate and we are human beings and we work on it. But at the same time, gosh, we expect scientific rigor.
You know, I understand that different definitions work for different purposes. And if dynamicists, people that study orbits, like to use a different definition for what they consider to be planets or dwarf planets or whatever, that's fine. It's just that really the textbook writers and the press ought to recognize what Phil Metzger showed, which is the larger planetary science community totally doesn't need that definition and uses a different one. And that's what ought to be in the textbooks.
Absolutely. And that's, how do we do that? I mean, you've had this struggle now for, gosh, the better part of the past 2 decades. What do we do? How can we possibly, besides having this?
Don't ask me. I've been talking about it for 15 years and it's not working. How would you do it?
I think traditional media, which I obviously don't work in, is probably still something that has weight. Which, although, because what's so great about this, we're getting lots of great comments. By the way, everyone in the audience, if you want to ask a question of Dr. Stern, he'd love to answer your questions about space and Pluto, and especially if you have highly technical questions too. There's no one who's more technically proficient in this field when it comes to Pluto that I know. Well, I say that who is present, at least. Yeah. And and then Laurel, who's a huge advocate of Pluto's planethood, asks, how about a direct approach to textbook publishers? Oh, by the way, Laurel, if you have the link handy to your blog, go ahead and put it here, and I'll put it up on screen. And also later, Laurel, remind me, because you're on Twitter or somewhere, to put a link to your blog in the description of the video so people can go and read a lot of actually the things that Dr. Stern has said about this exact thing. So, yeah, direct approach to textbook publishers. What do you think?
You asked about that, and I know PhD planetary scientists who've gone to textbook authors and publishers and said, here's the evidence. Your textbook is wrong. No one is using this. And the textbook community, the typical response is, when the IAU changes their mind, we'll change our textbook. And this is really unfortunate because first, they're relying upon non-experts, astronomers, not planetary scientists. Secondly, it's kind of a dogma thing. But most importantly, it's tragic because in science, we don't vote on things. We don't vote on the theory of relativity. We don't vote on quantum mechanics. We don't vote on breakthroughs in genomics. This vote that the IAU took on a scientific matter is the most pedagogically damaging act against science that I know of in my lifetime. It convinces people who think science is arbitrary that by voting that we can change scientific discoveries and facts. And we don't want people to think that, because then they'll think that research on any given topic can be arbitrarily voted down. It's just not how science works.
No,
and
it's not how language works.
Of all
either.
entities, textbook publishers should realize that's not how science works.
Yeah, absolutely. And language doesn't work that way either, because when you have a group, whatever that group is, whether it's a group of people that use a language, in this case, we have a group of planetary scientists who use various terms, that would seem to prevail as the proper term. But
and
it's
so
also,
if we're waiting for us to take another vote that overwhelms I know how to do that. That would be very easy to have more people vote in the planetary science community than the few hundred astronomers back in 2006. But the problem is those of us who feel strongly that science isn't about voting don't want to take another vote, because that would exacerbate the problem of making science look arbitrary. The real way science is done, take the theory of relativity or genomics or continental drift or whatever major theory. Scientists decide one by one until there's a consensus reached from reading the literature, hearing people give technical presentations, thinking about a theory, seeing the evidence for and against, and deciding. And then they step to one side of it or the other unless they're otherwise convinced to step back. But we do not vote.
Nope. It's a common use
So
term that's used by, yeah.
It's difficult to fight back when textbook publishers say, show me a vote that overwhelms the IU. Well, the problem is that's antithetical to science, having another vote. So I'm looking for ideas.
Yeah, I mean, if it's worth taking it to the, what do you call it? Not the shame astronomical union. I'm missing the...
Well, the irrelevant.
Irrelevant.
Yeah, that acronym is IAU.
We may not make many friends if we do that, but although I love calling it that because I think that's hilarious and appropriate if they, are not revisiting what's clearly an issue of importance, because it's people might argue, it's just it's a name, but like we talked about, it's not meaningless, these terms, because we don't like with the details of something in genomics, or as you were just mentioning about we can't go into explaining to every single person all the details, which I barely know anything about, of how DNA works, but we can understand, for example, what's a huge conclusion out of the Human Genome Project was that I think is really relevant, is that human beings are unbelievably close to each other. That in some ways, many ways, all human beings are more genetically similar to each other than related species of apes due to different evolutionary processes, which is an important message and helpful to know that, hey, yeah, we are really very similar, which is, I think, an important message for just our cooperation as a species, and putting idiotic things like racism far behind us, because science itself demonstrates how these similarities. And in the same way, we have what it reminds me of. It reminds me of Galileo writing to Kepler saying, these friggin' guys, it's a direct quote, these friggin' guys won't look through the telescope. They won't look at it. Yeah. And I feel like
it's Latin for frigging.
Let's say malum. I do know quite a few unpleasant words in Latin, but yeah. But malum astronomy, or whoever, these darn astronomers, they're not. They're considering with a completely different conceptual model, which is, I think, why you aptly said that they botched the job, which is about.
Well, they did it for cultural reasons, not scientific reasons. They just wanted to make sure that school kids weren't overwhelmed with a large number of names. Instead of thinking in every form of science, there are important concepts where we can't memorize as an average person. Take the periodic table. If we restricted the periodic table to 8 elements, we'd have to stop at beryllium. Does that make any sense, just to make it manageable for school kids?
Nope. It's pretty dumb to me, but we'll have to continue to do that, and with obviously the new forms of media we have, from the YouTube live streams to blogs to whatever we can, just to continue to repeat this message until it gets through, because it is, I think, really important to continuing to fund unmanned exploration, because
I think in the long term, there's no question that the IU definition will be some weird trivia footnote in history, that it's so far off and so overwhelmingly not used that it is just, I think, a matter of time.
Well, yeah, we can only hope with that one. Well, we can definitely revisit the debate, and then if you out there, if you have questions. Oh, wait, here. Oh, we have one from Jolt, who asks, how much chance had Tombaugh discovered Eris or another trans-Neptunian object instead of Pluto? I guess, are you asking Jolt if he had could he have with his available telescopes at the time, or did he accidentally discover something else instead of Pluto, and then Pluto was refound later?
Yeah, I think I see what Zolt is looking for. Tombaugh did look for other trans-Neptunian objects that are farther out than Neptune. He looked for decades, and like others, he didn't find any. Although there, back in that time, you had to not only have a telescope and a camera that was sensitive enough to detect these very far away things, but all of the data analysis consisted of literally by eye searching plates, glass plates. That was the technology of photography. By comparing tonight's photograph to last night's or last week's photograph to look for a little something that was jumping, meaning moving along its orbit at just the right pace to be very far away. And it was painstaking because some of these plates would have images with 100,000 stars and dozens, if not hundreds of not meteors, but asteroids going through the images. And it was just needle in a haystack problem. And they did not find anything. And today, the way that we do it is we program a computer to do this search, and computers don't get bored. They don't sneeze and skip a step. They don't wear out. They don't have a lack of concentration. And all of these objects are now found with computers. And today we have found that some Kuiper Belt planets were photographed even as far back as 1895.
Really?
35 years before Pluto was discovered. But no one knew they were in the images.
But now we can tell.
Until later, when the computers can find them, and then we can trace their orbit backward, again with a computer, and then match them against all photographs in all libraries, and then go and find the images. They're called archival images. So there were people back in the 20th century that were photographing planets they did not know could have been the career-changing discoveries of their career. And some of them went to their graves and never knew they had seen these bodies.
Yeah, well, that is amazing. I wasn't aware of that at all. Wow. Well, it makes sense though, because if they're just constantly photographing,
was photographed previously back to 1904 and 1905.
Wow.
Including by one guy who was looking for it, but just missed it because the job was so difficult. Tombaugh was good. His brain was amazing for just concentration and working through enormous amounts of data to find that needle in the haystack. And what's a real tribute to the guy is, 24 years old, he never once made a false claim. He never once had a false alarm. The one and only time he found a planet, it was real. And he was just tremendous at this, and a human computer almost. Just a machine for finding these things.
Well, thank goodness that there have been people willing to go through that kind of dull stuff for the hope of making a great discovery, which changes how we think about the solar system. I was just reminded of the looking into, this is more of an orbital dynamics sort of idea, but of a Planet X, which they have insultingly called Planet 9, that somewhat massive body, which may be way out there. I haven't looked at anything in the past few years, though. I don't know if that's been, if anything more has come of those studies.
That particular object was theorized in some very technically complicated papers by Mike Brown and a co-worker of his named Badigan. And now Brown and Badigan, along with many others, have looked for it, I believe for 6 years. They got nada. So I don't know if it's real or not. But we have very strong evidence that the deep outer solar system is littered with more planets to discover. Little ones like Pluto, and bigger ones like the Earth and Mars, at least.
Wow.
And there are multiple lines of evidence that are very hard to refute that we will find more and more and more and more in the outer reaches of the Kuiper Belt and in what's beyond that called the Oort cloud. And when the census is done, maybe in another century, if anybody watches this online, you're talking about way back in 2021, they'll know whether this was right or not. But I predict that the numbers of planets in the solar system, including the numbers of very large planets, is going to skyrocket.
That would be amazing. And having actually done a real mission flying to Pluto, what could we do conceivably in this century to make those kinds of discoveries? Do we have to put a Hubble-like or Hubble-capable telescope farther out there? Or do we have to put lots of actual exploratory probes like New Horizons? Is there any, have people thought of a technical solution for this?
Yeah, that's a great question, Luke. And in fact, the first steps that are going to enable the discovery of more planets are already pretty far along. There are two. One is the next generation of larger telescopes that go from what used to be the behemoths, like the Keck telescope with a 10-meter diameter aperture, to 25 and 30-meter telescopes that are being built by the Europeans and by two international groups called the 30-meter telescope and the Giant Magellan telescope. Mm-hmm. They're going to have so much more grasp that they can see farther because they have bigger light collecting mirrors. At the same time, we're starting to develop something called time domain astronomy, which is more or less taking movies of the sky and using massive farms of processors, computers, to mine all that data on a whole completely different scale than we do today. The National Science Foundation is building the very first big time domain observatory, which was originally called the Large Synoptic Survey Telescope, and has recently been renamed to the Vera Rubin Observatory, and it's pretty close. It's going to have first light next year, and it'll be operational in 23, just 2 years from now. And I think we'll see the discoveries of more planets with that tool, and then the big telescopes that are coming online later in the decade. But it's going to take still bigger and bigger machines and the next generation of time domain. Ultimately, my best estimate is the solar system, and this is based upon a published paper in a planetary science journal that I wrote with math and modeling, not just thumb in the wind, but multiple arguments point to there being north of 1,000 planets in our solar system. Not 9, think more like 900.
Yeah, and
amazing.
That is
no
amazing.
Of it.
We barely have 4,000. I mean, wait, exoplanets, much less. And therefore, the implication is that if our solar system can be paradigmatic for the galaxy and the universe, then the worlds to be explored is just mind-boggling.
Right. People don't say that where we live now in the 20-teens and 20s is where Star Trek began. They don't say that for nothing.
That's right.
You're really at the inflection point, I think. And I'd like to add one more thing, just an analogy.
Yeah.
So I live in Boulder County, Colorado. It's a little valley in front of the Front Range of the Rockies. And from that valley, when you're in downtown Boulder, Colorado, and you look out to the west, you see exactly 4 mountains. Okay, there's Bear Mountain, Green Mountain, Flagstaff Mountain, and Sanitas. And the Arapaho Indians that used to live in this valley might have thought those were the only 4 mountains that, the universe created, that their gods created. But if you ever climb to the top of any one of the 4 and you look west, you see a sea of mountains called the Rockies. Just crazy numbers of them. And I think that is analogous to the 20th century view that we had 8 and then 9 planets. And then now in the 21st century, we've got our tools so we can climb that mountain and look out and realize the solar system is teeming with planets. What a wonderful transformation as science advances to think about that. How many planets the solar system made, which makes, I think, the Earth and the ocean worlds that are likely to, at least in some cases, be habitable, it's all the more special. Most of these planets got ejected out into the far reaches in the early days of the solar system, and they're now so far away, they're still hidden from us, but our technology is improving and we will find them all.
Well, and that's the true excitement, the Star Trek-like excitement. I think that our this century, the next centuries will bring. A little comment from Kirby, who I loved your book, by the way, and he said that perhaps we, as a community of enthusiasts, should write to these publishers to try to get them to look at something, scientific, like the geophysical planet definition, which is good. And just mentioning some of the ocean worlds and rocky worlds, I had this little diagram handy showing some of the worlds in the solar system, including looks like ice worlds at the top predominantly, Ganymede, Callisto, Enceladus. Gosh, do I love Enceladus! I love that tiny little thing, and I'll call that a planet all day.
Hey, Luke, let me point out for not for you so much as for the listeners that Kirby's using the geophysical planet definition. By the way, Kirby is a early career planetary scientist with a very steep trajectory in his career, making important contributions in a number of areas. He's at the Johns Hopkins Applied Physics Lab, no backwater institution. He's a geologist and geophysicist by training, and a very good public communicator in addition. But the strict geophysical planet definition is very simple. I'll teach everybody, for anybody who doesn't know. It is simply a natural object in space that is large enough to become rounded by self-gravity, because we know planets are round things, and not so large or massive that its interior ignites in nuclear fusion. Those are stars, big round things that are on fire. And that's all there is to that definition. It's a natural object in space, big enough to be round, and not so big it's a star and ignites. And when you look at this potpourri of objects on the screen, some of them are moons of other planets, which the geophysical planet definition recognizes both as moons and as planets, because moon is really a description of location. And it just like I am a Coloradan, but separately, I am a Homo sapien. And there are different kinds of descriptions. And so the planet-sized moons of the giant planets count as planets. So does Pluto's big moon, Charon, which itself is big and round, because it is a planet that happens to be orbiting another planet. And if you don't like that, let me just say that all across the space sciences, when asteroids orbit asteroids, galaxies orbit galaxies, stars orbit stars, it's no different that planets orbit planets. And the fact that Luna, our moon, is large enough to be a planet and fits the geophysical planet definition and is separately captured into Earth orbit is a secondary detail about its location, whereas its planethood is actually about its nature. The same way that saying Homo sapien about all of us is about our nature, and then our zip code is about our location, or what state we live in, or country we live in.
Exactly, and it's the and that's actually one of my favorite parts about the geophysical planetary definition, that suddenly we properly get out of the Ptolemaic understanding, like it's basically, that's kind of how it's what it feels like. Oh, it's a planet. And I had debates recently, the past month, with astronomers and astrophysicists who seriously think that the dominant gravitational object should be the planet, and then the other thing's the moon, and that somehow scientifically or linguistically rational. And it just isn't. What this discovery, especially when Galileo was able to say, hey, there's mountains on the moon, and hey, look, the Jupiter has more planets going around it, essentially. That unfortunately, in the subsequent centuries, we've gotten into the idea of a somewhat mechanical orrery where you have the moons going around, where it's, as we know in actual physics, it's funny that we have to tell astronomers these things. In actual physics, these objects are all pulling on each other. And if we want to use that as some kind of measurement, okay, sure, you can call, you don't have to call the Earth-Moon system a double planet because the point around which they rotate mutually is within the Earth's crust, okay. While Pluto and Charon, of course, orbit each other, a point that's in space, that's naked, if you will, that they're orbiting around. And that, okay, and that's a nice little definition, but it doesn't matter. It's really an arbitrary thing where you just accrete more mass onto one until it, you pull it in. It doesn't really change, like you're saying, what the object is. And I think we should really embrace this idea of all of these worlds. World is thankfully a is not a very controversial term, embrace these worlds as planets and give them that name, because that does excite people about their exploration. I think that's a very worthy.
No doubt, I agree.
thing.
And by the way, we also want a definition that's resilient. And let me give you an example of that. There is a world, a planet orbiting Neptune called Triton. It's its largest moon. And we absolutely know from its orbit type that Triton used to orbit the sun and happened to get snared into Neptune's gravity, where it now orbits. It was a free-floating planet of its own, larger than Pluto, which now is a planet orbiting Neptune. But the fact that Neptune captured it and made it a satellite does not make it a planet still. It's just in a different zip code. It's the Neptune zip code now.
That's right. And I think I got it here. Right. Yeah. And which another, it's so, I would have never expected Pluto to be even more just surface value, beautiful and interesting looking than Triton. But it makes sense, because if it's another similar type of object, that it would be comparable. And we had a little, we had this from David Siebel asking, if you could send another probe to visit a trans-Neptunian object, which would it be? And secondly, what is the range of these objects?
I'm not sure what the second question means, but
how far away are they? Maybe.
Yeah, maybe how far, or how big a variation in their size. So we now know of a couple dozen planets that are farther out than Pluto, in addition to the closer planets of the solar system. And they're a very heterogeneous group. They have different numbers of moons, different colors, different compositions, different densities. They're every bit as heterogeneous as the 4 terrestrial planets, Mercury, Venus, Earth, and Mars, if not more so. And this region of the solar system deserves a lot of missions, not just 1 or 2. But there are several that are particularly enticing beyond Pluto. And one, which I think is a very high priority, is to go back to the Neptune system with an orbiter to study Triton, even bigger than Pluto, along with everything else in the Neptune system. This would be the first orbiter of an ice giant planet. That's what Neptune is. It would be the first chance to really study the whole satellite and ring system of Neptune in detail, which Voyager only, more or less spent a weekend at Neptune on its way through the solar system, and do it with modern instrumentation. And then beyond that, the faraway dwarf planet Eris is a particular favorite of mine, has some analogies to Pluto, but the opportunities for exploration out there are huge. We should go back to Pluto with an orbiter and eventually a lander. If it's got the ocean inside that we believe it does, then we should be down in that ocean eventually and looking for whether there's astrobiology there. There's some reason to think that might be the case. We could talk about it. But we should also be making reconnaissance missions to sample the diversity and variety of those dwarf planets in the deep outer solar system. I think New Horizons showed us how valuable that kind of mission can be, and we should be mounting 5 or 6 more of them, not arguing about which one should be next.
Yeah, and we had someone asking about what you're feeling about SpaceX. One thing that I have is I love everything that is going on with the construction of Starship, and I watch it avidly. But what's so exciting to me is, even if that thing doesn't transport a single human being, the fact that it can launch so much payload in the form of multiple New Horizons on one launch, and just start flinging things out into the solar system. That's a game changer in my opinion. But I don't know if you had any more thought about that. Have you?
Starship is inspiring, and it will give us capabilities we don't have today for many kinds of space exploration, both human and robotic. But guarantee you, 30 years from now, we'll look back on it as the Model T of 21st century launch vehicles and 21st century space exploration. One thing that we need that has nothing to do with launch is we need better in-space propulsion. We need to really develop atomic power because it's so much better than the forms we use today. So it doesn't take 10 years to get across the solar system.
Absolutely.
We can be crossing to Pluto in 1 year with the right developments in technology.
Yeah.
And what else? What else is Star Trek about but getting to faraway places in a reasonable amount of time?
Especially with the idea that our solar system could have thousands of worlds worthy of exploration just out in the Kuiper Belt alone, not to mention what could be in the Oort cloud. It's like, wait a minute, we don't actually, as much as it'd be wonderful to have warp drive and whatever theoretical technology, if we have just advanced, oh gosh, the technical name is escaping me at the moment, but what gosh, they're working in the 60s, NASA, the nuclear powered.
Right, like the NERVA program.
NERVA, thank you. NERVA, being able to actually use a nuclear reactor to heat hydrogen as a propellant with a great specific impulse, being able to get out there, basically twice as capable and as any.
If you don't mind my saying, some people get nervous about using radioactive things in space because first you have to launch them off the Earth. That doesn't always work. I get that. But aside from reactors, which are a very enticing technology for spaceflight, in-space propulsion, we currently more or less have sailing ships like New Horizons. The fastest spacecraft ever launched beat the pants off of Voyager for speed across the solar system. All of that was given to us by a giant rocket and one gravity assist from Jupiter. All the rest of the time, we're coasting. We're not thrusting and going faster and faster. One of the really promising technologies for propulsion, which turns out to be easier for propulsion than it is for power generation, is fusion. This involves no radioactive material. And there are companies like HelicitySpace that I'm an advisor to that are working on this. This is true 21st century, 22nd century technology for in-space propulsion. And it's within our reach by the 2030s.
What do we need to reach it to have fusion propulsion by the 2030s?
We need companies like that to be successful in raising the capital to go make demonstration models of this, first in laboratories, and then put them in space and fly them. The technology is available to travel at speeds 10 to many tens of times faster. So a crossing to Mars doesn't take a year or two for a human crew. It takes a month or two, or less, maybe only a couple of weeks, like a cruise ship going across the ocean. Imagine how much easier the settlement of the solar system will be when we can fly at those kinds of speeds. And that technology is just a little beyond our grasp today.
Wow. And I just grabbed this quickly. Is this what you're talking about, Helicity Drive?
Yeah, and you could also take a look at the website for the company as well. Just Google up HelicitySpace.
HelicitySpace. I'm doing that right now. Everybody Google that. And what we fans of this out there who are watching, how can we support Helicity? Just through awareness or telling people about how cool it is?
Follow what they're doing. I can't talk about some plans for later this year, but there's going to be a chance for the public to get involved after Silicon Valley gets involved. And I think it's going to be super exciting.
Wow. Well, that is... Oh, there you are. Gotcha. And by the way, I noted how your given first name happens to be spelled the same as a day on Mars. So I thought that was really cool.
It's also the name of the sun, Sol.
Exactly. Yeah, it works. Yeah. It's perfect.
That was my grandfather's name. Yeah.
Oh, that's a great name. And wow. Okay. Well, that's really cool. Now, what I want to talk about now, Dr. Stern, is one of your papers, actually several of them, but whatever we might have time for today. But before we get to talk about this paper, I want to give you the chance, if you wanted to take a break at all, absolutely we can do that before we get into some of this really cool geophysics.
Thanks, Luke. I don't need a break unless you think we ought to take one for everybody else.
No, just wanted to give you the chance. But okay, well then in that case, I'm thrilled by this article because ever since it was within weeks that there was comments coming from the team saying that, we have a whole field of cryovolcanism. We have all these amazing things. We have the lack of contraction being very visible on the surface, but instead expansive features. And since 2015, I've still just been absolutely boggled how on Earth, that's terrible. How in the solar system is it possible that an object so far away from solar insolation, from any kind of significant heat source. It's I don't know if it's not in the middle of deep space and out between galaxies, but it's getting very little. Yet it has the ability to drive more complex geology than currently on Mars. How can that be?
It's mind-blowing. And I have to say, we did not expect that. We expected a lot of spectacular things at Pluto. That was not one of them. And, now it's been 6 years or 5.5 since the flyby of Pluto and the torrent of data that came back from New Horizons. And there are two very important threads in the science about Pluto. One, there are multiple lines of evidence that Pluto contains a liquid water ocean in its interior. In fact, we see evidence for eruptions of that liquid water ocean onto the surface, and lo and behold, where we see the water that is frozen from those eruptions, we see organic material, which suggests the ocean is teeming in organics down in Pluto's interior. And the second important...
Oh, I'm sorry to interrupt you, sir. I just wanted to say organics, people usually associate organic with true biology, with living things, but organic compounds...
I mean carbon and hydrogen-based chemistry that can be the precursor to biology.
Indeed, exactly. So you're saying another one.
Molecule is methane, natural gas. Right? Exactly. It's not alive; it's a molecule. We burn it in some types of kitchens.
Right.
But use it for home heating all around the world. It's just one carbon and 4 hydrogens bonded together in a kind of a tetrahedron of a molecule.
Right.
And then ethane and ethylene, and then much more complex hydrocarbons as you go up to in complexity. And those are the kinds of things that we see on Pluto's surface associated with the water in the places where it has apparently erupted from fissures, tectonic features on the surface of Pluto. But I was going to say, there's this second line of evidence, apart from the evidence for the ocean, that Pluto has been active throughout its 4 billion year geologic history. We see ancient features across the surface, and we date them by how many craters are on the surface, telling us how old they are. We see very young features, basically born yesterday geologically, the largest of which is the left or western side of Pluto's heart, Sputnik Planitia. This is that's a topographic map, and there dark things are holes in the ground, and bright things are raised features like mountain ranges. This map was made with New Horizons data, stereoscopic data, to create a digital terrain model. But we also see lines of evidence for activity at Middle Ages for Pluto. So across the whole spectrum. And Sputnik is a great example. It is the size of Oklahoma combined, more than 1 million square kilometers. And it is alive today. It has no craters on its surface, which means that it's reinvigorating, renewing its surface all the time through a process called convection, where there's a thermal heat source below causing the glacier to overturn all the time. And how Pluto creates these things the size of Texas and recreates it. Over 4 billion years, Sputnik has been recreated probably many thousands of times, because the turnover time scale is about 1,000th of the age of the solar system and the age of this planet. How does Pluto do that? No one really knows. All we know is that's what we discovered.
No, you have to have the answer, Doctor. I've been waiting for 4, 5, 6 years now. I need to know. And I know. It's we
sorry, Luke. We have ideas, but we don't know which one is right, or if any of them are the right idea. Well, we need to go back with that orbiter, because we need different kinds of data to find out.
Well, and I definitely want to talk about that too, and because we have 2 models. A cold start one, which I think was maybe the traditional way that we'd assume an object like Pluto ought to have formed, and then the hot start one. And in the lower diagrams, we'd see a tendency towards compressional features, because the planet cools, it would shrink, and then we'd like on Mars, for example. I was looking at wrinkle ridges a few years ago on Mars, actually, and you see that compression which comes from the cooling of a planet, and yet we actually observe quite a bit of extensional features, just as you were saying, instead, which is...
Right. This is the Bierson, Nimmo, and Stern paper of last year published by Nature, which is a top flight scientific journal. And Carver, who's a PhD student under Francis Nimmo, the middle author, a geophysicist, took an idea of mine and really modeled it carefully in the computer to ask the question, what if Pluto didn't get assembled cold and then heated up due to radioactive decay of materials in its interior and other geophysical processes? But what if it formed quickly and trapped a lot of heat in the interior to begin with? What does that say about the types of geology that we should see expressed on the surface, and which model, the cold start or the hot start model, fits the maps and features that we see from New Horizons better? And the answer came out, the hot start model. And that model has important implications for an interior ocean, but it also tells us things about how Pluto may have been formed almost in the blink of an eye, geologically, in a space of tens of thousands of years, which is forever compared to a human lifetime. But it's literally the blink of an eye on solar system timescales. And this paper is really got a lot of traction. There's a lot more work that needs to be done, because you always do a first project where you try to simplify all the physical processes as much as possible to see if more work is warranted. And in this case, a lot more work is warranted. And Carver's just emerging from graduate school with his doctorate. And other people are interested in this problem too. And I think we're going to see more published on this this year and in the coming years, because it's got a lot of promise.
Yeah. Well, so this is obviously, you're, as a co-author in this paper, I assume you think that this is plausible, and yeah, I'm kind of like I was just wondering, like, well, besides this, which I also think is a compelling model, yeah, it couldn't be. I mean, the first thing I think of when I think of bodies outside of the inner planets that have complex geology, I think of gravitational tidal interactions between, like in the Jovian worlds, or with Titan. I think likely, right? Isn't that? I haven't actually looked at the Cassini data in a while, but I assume Titan's internal heat, which permits a lot of its geological activity, is thought to be partially because of gravitational interaction.
I think it's a minor term. I'm not expert in this, but we know in the case of Pluto, which is a double planet with Charon, that tidal energy generation was very important very early on. It's not any longer. So there has to be some other mechanism. I'll tell you my favorite. And I have not worked on this in the sense of computer modeling, so I don't claim that it's right or the best idea, but it's the most philosophically engaging, is that we have all this evidence for an interior ocean. And we know that as time goes by, that the planet must be cooling, and so the ocean must be freezing. And when water freezes, it releases an energy source called the latent heat of freezing. And it may be that the ocean is the battery that is keeping Pluto alive. And the fact that Pluto is so active after 4.5 billion years is further evidence for that ocean. So it's sort of a passive heat source in a way. But there are 4 or 5 other models as well, including the ones that you mentioned and a couple of others. And we'll just have to see. We're very early days in digesting the treasure trove from New Horizons, and we need new types of data to give us new constraints. And I'll give you one example. There's a recent paper by Denton et al. That's just been accepted for publication. That's based on some work that my team did, looking at the low resolution images of Pluto's far side, the side of Pluto that New Horizons only saw in the distance.
You do have low resolution images. I've only seen the atmosphere photo. I didn't realize you had it.
We have images that show us. And the interesting thing
radar
is,
or what?
No, by photographs. As we were approaching Pluto, we took images every single day.
Yeah.
And it took 6 days to turn on its axis. We flew by one side on one day, but we have good images of the other side, not as good as what you're used to looking at, but a heck of a lot better than from the Earth, 100 times better than from the Earth, made just 3 days out. And the most interesting thing is, and this is what Denton et al. Have put in computer models, is it looks like there's a bunch of chaotic terrain exactly antipodal or 180 degrees to the Sputnik impact basin. which may have been the result of shock waves from the formation, the collision that made that impact basin, all being focused and meeting again halfway around the planet and jumbling up that terrain in titanic earthquakes. Now, the interesting thing that Denton et al. Found is that doesn't work for any arbitrary model of Pluto's interior structure, but it works really well if there's a liquid ocean which can act between the rock below and the ice above in a channel like a waveguide to focus those seismic waves 180 degrees away.
Incredible.
Yeah.
That is tantalizing.
More and more work being done, and we're starting to figure out just how hard Pluto is and how much we need an orbiter. And I hope we get to see that.
What would you name it? The Pluto orbiter.
Whatever people want to name it.
There you go. Yeah, it's it's just so interesting, man, to have a Pluto orbiter and then to be able to look more closely at Charon and the other four moons. Wait, let's see if I memorize them. Nix, Styx, Kerberos, and what's the other one?
Wait for it. Come on.
Oh gosh, now I'm embarrassed. I should know it.
Come on.
Hold on.
Nine-headed guard at the
Hydra.
gate. Hydra.
Right, the enemy of S.H.I.E.L.D. in the Marvel Cinematic Universe. I highlighted some things here I wanted to either comment on or ask about. Yeah, the wrinkle ridges would be hard to reconcile with a hot star Pluto. We don't have. Don't recall seeing wrinkle ridges on Pluto. Have you seen any?
No.
No.
But they could be on that far side that we don't see in detail. We do see extensional tectonics, as you mentioned earlier. It looks like the planet expanded as if that water ice ocean, which was all liquid to begin with, has since started to freeze and created those extensional forms. We see that on Pluto's large moon Charon as well, even much more clearly. Yeah,
which seems more like, except for the beautiful bit of spackled paint it got on it from what appears to be cryovolcanism with organics in it, right? That's
methane escape from Pluto that's painting the polar surface of Charon. Yeah.
What a pretty color too.
Sci-fi world, huh?
It is. It really is.
Now, imagine mountain ranges that go for hundreds of miles, made of not rock, not even water ice, but giant methane crystals that reach thousands of feet into the sky, and all the blades of the mountains are aligned for hundreds of kilometers. There's no terrain like it anywhere in the solar system, except at Pluto. We've never seen anything like that before. And it appears to be very common across Pluto's far side. We only glimpsed it on the edge of the near side.
It's what's so cool. And ever since I started looking at Titan many years ago, and just to kind of maybe help some of our listeners picture it, because the temperatures get so cold out beyond the orbit of Mars, essentially out past the asteroid belt, that water ice tends to get so hard that it's not merely a rock. It is in fact a rock and a mineral, technically speaking, but it becomes as hard as our rocks tend to be on the Earth, and therefore acts like that. And when you have a whole crust that's made of ice, it's not something necessarily very fragile at all, but can act very much like, with some different kinds of plasticity, obviously, but it can act a lot like mountains, as it does on Titan, where the mountains are made of ice and the water is the liquid that precipitates is made of hydrocarbons, and is yet colder out at Pluto. So you have an even more interesting.
Yeah. The outer solar system is truly a science fiction land, and there's all different kinds of worlds. From Titan, which I think in the middle solar system is the belle of the ball, as you say, a world where liquids flow on the surface, and all kinds of exotic chemistry, organic chemistry, take place in the atmosphere, to places like Pluto, to Triton, to Enceladus with the geysers, to the the near ubiquity of interior oceans in the large worlds of the middle and outer solar system. We are only beginning to appreciate how complicated the solar system is, how many planets it has, and to even begin to understand the census of the worlds that we should eventually explore, first with robots and then with humans. There's a lot of work ahead.
Yeah, it'd be I can't wait. I'm really excited about what we can do this century. Laurel asks, could a nanosatellite be sent to Pluto as an orbiter theoretically? My immediate thought there is you need to have a significant propulsion system which can slow down after getting there. What do you think, sir?
There are some crazy ideas for doing things like that. I say crazy because you'd have to develop a number of different technologies. How to power it, how to communicate without a large antenna and very much power, how to bring it to a stop, and how to fit all the sensors you need. I think if we send an orbiter to Pluto, it's likely to look something like a modern day Cassini or Galileo. It's done with a generations later technology. And everything else is actually harder, even nanosats, because you have to invent so much we don't know how to do that you could just as well have done the project using current day technology for that.
Something like the talk of Stephen Hawking before he passed away was talking about tiny nano probes being sent by means of laser to other star systems, something which is technically mostly an engineering problem. But what I always wonder, well, what can you get with that if you have something that's really small with a good enough camera and radio system to even be worthwhile?
Yuri Milner and Pete Worden and the Breakthrough Foundation are working on just that. And Milner, who made his fortune more or less giving birth to the internet in Russia, and then who came to the United States, is funding a lot of that research. I hope it pans out.
Yeah, me too. And I'd say talking about the engineering challenges a little bit to get the orbiter, and that's the biggest part. It goes really fast and it has to slow down, and it's not a massive planet like Jupiter or Saturn where you can do gravitational assist to swing around and then just smooth out your orbit into something circular easily. Obviously, that has to be done, but do we lack? Okay, what we have available now is Falcon Heavy, which is, I think, the heaviest launch vehicle currently available, and it's expensive. What's that?
For a little while.
For a little while, till we have Blue Origin coming along with New Shepard and New Glenn and others soon.
We got Vulcan from ULA.
Vulcan's super awesome.
And we got Starship. We seem to going to have SLS. We'll see.
And you were talking about the new technologies, and of course SLS, with the Europa Clipper. But with current and very near future, at least launch vehicles, can we launch something with a mass that's necessary for a retro propulsion system that can actually make it, or is that still out of our reach?
We absolutely can. I led a study a couple of years ago and published it in the AIAA Journal of Spacecraft and Rockets. I believe 2019, with my name, so you can Google it, on a Pluto orbiter study that we did at the Southwest Research Institute, where I work. And we found it's entirely doable with current day technology and current day launch vehicles. And then since then, NASA funded a study that Dr. Carly Howitt did subsequent to the one I led that looked in even more detail at this time with government funding, and came to the same conclusions. The only disappointing bit is that, it's affordable and it's doable, but it's going to take a long time because New Horizons could just go screaming across the solar system. And with the sensors designed properly, catch all the data we wanted to get on a fast flyby. To actually come to a stop to get into orbit means that the traverse across the solar system takes much longer, because the first half you're speeding out there, the second half you have to be braking. And it turns out that it takes, or maybe a little longer than 20 years to get out there and into orbit before you can even begin.
And we don't even have anything on the books. So we're talking about mid-late 21st century at the soonest to do something like that.
If somebody said, let's go build that, here's a check, we could launch it, let's say the end of the decade, the beginning of the 30s, it wouldn't get there until the 50s, early 50s, 30 years from now. And then it would return its results. But we're stuck with that technology. What HelicitySpace is doing and many others, and even larger rockets than the current monsters that are about to come online, like New Shepard or Starship, that generation of rockets and that generation of in-space technology could get us there faster, but by the time that you develop all that and then fly it, it's probably a tie. you'd get there more quickly in flight, but it would still end up being the late 40s or the 50s before we could get back.
Yeah, that's definitely sad. I feel that way because of how few. There's almost nothing robotic on the
I
books
got to
for
tell
Mars,
you,
even.
I will tell you a story. When we first started working on trying to get a spacecraft Pluto, and we thought to ourselves, 2015, that's not even a real year. Right? Somebody joked that we wouldn't be using MS Word by then, that we would be using MS Thought. And
that's funny.
And now 2015's, in the rearview mirror, half a dozen years. And so think, we started in the 80s and we got to Pluto in 2015. Putting an orbiter there now, whichever the two routes that I just described, the new technology route or the current technology route, gets there about as far in the future now as the 80s are in the past. It's a while back, but if you really want it, you can get that done. We did it.
That's right. And all you did, and just the fact that we got to see the side of Pluto which has a heart, which has done such great PR for the planet and our public conscience. Thank goodness. Like, just that, because what if you had seen maybe the other side's really boring, like with the first Mariner probes that went past Mars. They only captured the southern hemisphere mostly, and they were super boring, relatively speaking, more like the moon. Like, Mars is a dead world, and it took a long time until Viking, I think, to really get people excited again about, wow, Mars is this Earth-like world, not a moon-like world.
So we actually spotted the heart on Pluto, called Sputnik Planitia, with the Hubble Space Telescope, but the images were blurry enough to see there was this giant bright feature, which had an anomalous composition of nitrogen ice laced with carbon monoxide and methane ice. But we couldn't really see the beautiful shape of a heart, just a blurry patch.
Did you target it then for that time?
We targeted for that. We specifically decided to target for that. And we had no idea that it would turn out to be one of the loveliest, surface features in the solar system in the true shape of a Valentine's heart.
To me, it's just as famous as Valles Marineris now. It's unmistakable and so important. Something
very few people know is that when we were approaching Pluto after the 9-year journey across the solar system, after a lot of discussion within the team, we selected a theme song for the flyby. And any of you out there can go listen to it. The words are very appropriate. It is the theme song to one of the Star Trek franchises called Faith of the Heart.
Oh, no, Enterprise. I've seen every episode.
Yeah, that was selected as our flyby theme song, not knowing that Pluto would have a heart on its surface.
And you know what? That theme song, because I've been a Star Trek fan since I was an infant, and I remember watching Enterprise. The first couple seasons weren't that great, and the theme songs felt like something that Brandon Braga, who was one of the producers, was trying to do to be kind of annoying. It was like, just turn your sound down. Like, it was like, meh. So a lot of Star Trek fans like myself were very avid at that time, were kind of resentful towards it. But in retrospect, especially with the, I'll say, lower quality of some of the new Star Trek productions that have come out since, looking back on Enterprise is like, oh, actually, this was, especially the fourth season, was amazing. So and that theme song.
When we had a lot of ideas for possible theme songs, and first of all, I knew that obviously I heard it in the 90s and I knew the tune, but when I looked at lyrics, and it brought me by the heart myself, because for those of us that worked on this against long odds, the opening lyric is something about
it's been a long road, getting from there to here,
but our time is nearly here. It's like the 2,500 men and women that worked on New Horizons to build it in anonymity and fly it across the solar system and take big chances in their careers, because if this didn't work, it wouldn't be good for any of us. And it did. It's so paid off. And more than the science or the soft power projection for the United States of America, more than how great it made society feel that we can do great things in this century, is the lives it touched, that I've heard from more students and more adults who've just said, this has been my inspiration. And for me as a scientist, to think that we could touch people's lives, not just do science and produce new knowledge, and maybe set some records that go in the Guinness Book, but to actually inspire people is the most important outcome and the most important gift of New Horizons. And if any of you out there read this book, there it is, Chasing New Horizons. The last 3 pages that are the coda to the book tell that story. I think it's some of the most important pages of the entire book, just those 3.
I agree. Yeah. It's and everybody, just we mentioned it earlier, but if you joined us late, the link is in the description on Amazon to go get this book, and it's worth reading. It's meant for anybody to be able to read. Although we talked a lot already about some detailed scientific stuff, because that's a huge interest of mine personally, and I know some of you. The book although it covers the impact of everything in great detail, it's meant for everybody to be able to enjoy and to read and to really feel, like you're part of it. Just like all the wonderful, somewhat retro shows like For All Mankind take us into the hypothetical drama of a different space race, or even The Expanse, which again, it's the human story, which is what's part of it, and more than anyone else, you've gotten to almost as close as you could to physically explore the world with every possible extension of your own senses, as the PI and everyone on the team explore that system, which is that's meaningful, because that science isn't about cold data exclusively, for sure, but about that impact on our worldview, especially. Matthew Barkley asked some things that you've, I think, already talked about, Dr. Stern, but I just wanted to acknowledge, Matthew, that I think we have hit on it. But if you have any others, Dr. Stern, and then you go ahead. As far as he asking about important implications about the discovery of Pluto. I can think of a few, but go ahead, sir.
Well, I'm curious what you think are the most important things.
Well, the fact for me is just seeing that a hypothetically icy place is so dynamic means that perhaps we need to rewrite our Jovian moon analysis a little bit, or at least add some more energy on the formation side. Perhaps the tidal model is exactly right to explain the internal heating on the 5, or 6 that include Triton worlds of the gas giants that are orbiting the gas giants. So Triton, Titan, Io, Europa, Callisto, and Ganymede. So that's like I mean, and then of course what it means. Oh, and I underlined in one of the papers that we haven't looked at yet, but in one of the papers you were co-writer on, it said about the habitability, and it was this little thing at the end of the conclusion about habitability of the worlds, and we don't want to overexcite people about, because we still have not discovered actual biological things alive on other worlds outside of our own yet, that weren't, say, maybe transported there by a Earth rover on the moon or something. We haven't confirmed it yet, but so I think, especially in planetary science, we don't want to overexcite people and say, hey, we found life, because they found stuff on Venus, as you know, very recently. But at the same time, but I noticed, I think, what you were doing in that paper to say, hey, this is an ocean world, practically put. It must be, given what we're seeing on the surface, just as Enceladus and these others. So, I think that's a huge implication. The possibility that life, which is so fascinating to us scientifically, could be everywhere.
Yeah, I'm fascinated by the fact that of all the species that have lived on the Earth, only the humans have realized that the sky was not part of this Earth, but other places. And that somehow we are driven to not just appreciate that, but to actually go there. That's just mind-blowing, isn't it?
It is. And I often have thought about that. There's a lot of my listeners are very much into Latin, and there's a great piece by Cicero, which is also fun to read in translation in English, called Scipio's Dream. And he's writing about Scipio, and Scipio is like Scipio Africanus, who was the guy who finally conquered Hannibal in the Punic Wars between Rome and Carthage. And he talks about basically an ancient historical figure having a dream where he gets to meet his ancestors, and he goes up into heaven to do it in his dream. And when he does, he looks back and they talk about everybody in the solar system, or everybody that was known at the time. And that perspective, is that desire in dreams and in literature to really explore, has been around for a long time. And then there's a Greek author, Lucian, from the 2nd century AD, who wrote basically the first science fiction fantasy novel. It kind of reads a lot like Star Wars. They go to the moon and they go to it's unbelievable, the kind of imagination done with relatively little information at the time about what the places are actually like. And I think that is part of what we are. We've always looked at the stars. And
I have a paper that I'm giving at the Lunar Planetary Science Conference this year. It speaks to the fact that the ocean worlds are common in the galaxy, not just our solar system, and that if some of them actually not only develop life, but go on to develop intelligent life, that they may not know because there's a roof of ice and rock overhead that there's a universe out there. And they may never think of space exploration because they don't think of anything beyond their ocean because they can't see it. And they wouldn't know to want to explore it.
Exactly. I've thought about that too, that because I've had little fantastic ideas about what might be under Europa's icy shell, and some kind of cephalopod octopus creature, since the octopus...
Probably not any planetary scientists or any astronomers.
Oh, probably not, because they haven't had we doubt they've ventured up to the surface, if they exist, these hypothetical sentient beings, that something like In the Abyss, that lovely James Cameron movie, that could be down in Europa. But yeah, they wouldn't necessarily conceive of such an existence if they were even capable of reaching the surface.
I've given a couple of technical talks on why this may be part of the solution to the Fermi paradox, because the ocean worlds are very common, the interior ocean worlds. And they have no interest in communication. They don't know there's a universe out there.
Yeah, exactly. That would be, gosh, the possibilities are endless. And I feel like we just started Dr. Stern, but I promised not to go over an hour and a half, and I wanted to make sure I kept that. If you're interested in talking with us again, I know we'd love to hear from you and everybody out there. One more time, link to this wonderful book, Chasing New Horizons, is in the description. Definitely look into it. Also, Dr. Stern's written a lot of books. If you search for his name on Amazon, you'll find others too. But I can definitely recommend this one. And more than that, if you have other questions about these topics, then write them in the comments to this video after it becomes a permanent video on YouTube. And yeah, I'd love to read them. So,
well, Luke, thanks for having me. This was a great conversation, and you're amazing. And I'd come back anytime.
Oh, thank you, sir. Well, you're amazing. Keep doing all these things you're doing. It feels like you've just started. Keep doing everything and inspiring us to at least to discover along with you all these great things. Thanks so much for being here.
Absolutely. Thanks again for having me.